we're going to do some roughing out. So let's have a look at the process of doing some roughing. It's also can be referred to as adaptive clearing. There are two types of adaptive clearing we are going to look at. We're going to look at 2D adaptive clearing and 3D adaptive clearing. The big elements to think about are what material are you going to select to be removed and what is the tooling that you're going to use. So there's a few tabs that we will need to look at. The geometry tab, which will allow you to define what the boundary is if there is rest machining. So if you're starting from a partially finished part, you can say rest machine, so it will only look for geometry that hasn't been removed. You can make sure you can set your tool orientation if you are doing 3+2. For Fusion Ultimate, I mentioned before, it has very few differences than standard Fusion. One of those differences is multi-axis machining. So again, if you have someone who just has a bridge port and they're just going to be cutting 2.5, or they have a simple machine that's only going to be cutting 3 axis, they probably won't benefit from having Fusion 360 Ultimate. But it is important to really understand, if you're going to be training, then making them understand which version of the software they're going to be needing. So hopefully they're saving money to give to you as training, which is great. The Heights tab is used to establish the clearance for the movement of the tool, the rapid movement of the tool, how far down the tool should be cutting, where the tool should begin cutting, so the top of the tool paths. The Passes tab is related to controlling what happens whilst the tool is engaged with the material. So how deeply is it cutting? How far down the flute is it cutting? What are the step over distances? What are the step down different distances for roughing? The Linking tab deals with what happens between cuts. So after a cut is made, the tool needs to be relocated. Does it lift all the way up? Is it just a minimal retraction? What efforts are being used to keep the tool engaged? So those are the primary tabs. There is another tab that comes before the geometry tab, which is the tool, where you can select what tool will be used. So let's have a look at some of this in action. So what we're going to do, using this adaptive clearing, we're going to do a quick 2D face operation to skim the top. Then we're going to look at some 3D adaptive clearing for this surface around the model, but not the little pocket at the end. And then we're going to look at doing some 2D adaptive clearing for this section here. So if I now open up, so it's not actually this model anymore, so don't save that. If we now go back one into adaptive clearing, we've now got a new model. So as it comes up, again, I'm just going to X out of that. So we have the same setup orientation really as we did before. It's just by using this standard model, we ensure that we didn't make any mistakes that are going to carry through to this. So now we don't always have to start out with 2D toolpaths, but for this one, we will do an initial 2D toolpath using a 2D face. So up at the top here, we've got 2D. You can see there's a number of different alternative machining strategies that we've got up there. This one, we're just actually going to click on 2D face. And you'll see it's brought up this pop-up box. Now, normally, when this pop-up box comes up, if I can grab hold of it, it's normally a little bit smaller like that. The only thing is you get the icons up at the top, but it's nice when you're training somebody, if you can open it up a little bit, you actually get the names as well by the side of the actual icon. So it gives you an idea of what tools you're using. So first of all, what I need to do is select the tool. So if I go to select, this brings up my tool library. Let me just bring it down a little bit. It seems to have somehow gone right up at the top. Where are we? There we go, got it. So bring it down, I'll open it up a little bit. Now there is a massive selection of tools that are built in to Fusion and setups. We've got some vendor catalogue, so Renshaw's, Albrecht. Also, as tools are used, they build up in a library that are used in the design. So as you're building them up, you can actually build your own library. So there's a lot of sample tools already built in. They're actually built in with the speeds and feed rates set on the type of material. We also have the availability to be able to filter what tools we have available for us. So if I click on here and I want to do a bit of facing, and click face, okay, it reduces, and then it asks me what dimensions do I want. So I can change the information here, and as I'm searching through the catalogue, it will give me a selection of different type of cutters. I can also add my own, so I can take a tool and I can copy it, and I can maybe change the length of it, change the diameter of it. I can add tool holders, turning tools, and there's quite a few options there. So there's a lot of filtering that you can do. I will select, what I'm going to do is select this 2-inch face mill, and you can see what it comes up with, the tool information. So I'm scrolling down there, it's telling me it's a 2-inch, cutting diameter 2-inch. It gives me all the information on the lens, the shaft diameters, etc. The holder, well, there actually, I don't think there's any information on the holder there. You can see all that information comes with that particular tool. If I press OK, this comes in. I've got an option there for coolant. Just put flood on, just leave it as flood. For a facing operation, there isn't really any geometry to select. So if I go into geometry here, there's not really anything to select because I'm just doing that top face. Unless you can, if you want, you can limit the stock selection or stock area that's going to be faced. So when I click on the geometry tab, you can see it highlights the top of the stock. So that's that yellow line that's going round. For your heights, moving to heights, that's automatically generated too. So if I zoom in a little bit, the bottom height will always be detected as the model bottom height. So come around there, you can see all the heights. Now this is just, remember, this is just a facing operation, so it's just doing the very top face. Passes control, as I move into here. What happens when the tool moves? One option you might use is setting a pass extension. When we're looking at this now, and the passes, it's starting from, the tool will start from the top here, and it'll go across, and it'll just go to the end here, and then it'll come across and then back again. It might not always machine, far enough across. So what it's good to do in the extension, if I'm using a 2-inch, if I come 1.1 inches further across, what it will mean is my tool will actually come over that side there, and I actually went into that before I pressed enter. So, but I can go back in and I can edit it. So I was in the passes there. So it'll actually, my tool will come out, it'll extend past this edge, it'll move up, and then it'll come back again across, it'll pass this edge. So it'll make sure that I've gone over halfway across. The last thing is linking. We will leave that alone. And if we just say OK, which I think doing before, now it's calculated now my facing pass across here, and you can see the tool pass has a bit of colours. We'll see it more with other operations as we go along. The red is a rapid movement. The yellow is when it's moving to engage or removing. The blue and green is when it's actually cutting. So you can actually see that the different portions of the tool there and the tool movement. The next thing we need to do is start removing a lot of the material of this. So what we've done, we've got this solid block. If I actually just view this round a minute to the side, that tool path, you'll see it's above where we are. So we've got a stock box that goes across, and all we're doing with this tool is just facing it flat on top, so that we know we're all at a certain height all the way across. The next thing we're going to do is actually do some clearing, and we're going to try and get rid of a lot of this material around our handle or around our model shape. Now, because of the shape of this geometry, we're not going to use a 2D roughing strategy. We're going to use a 3D roughing strategy. And again, there are a lot of different 3D tool paths. So if we go in here, you'll see there's a lot of different types of tooling paths and strategies that we can use. Well, all we're going to do is just use I think on this one, where it's roughing, I think we're just going to use the adaptive clearing. There. Again, we get the same pop-up box as we did before with the same sort of tabs. So every time you're doing a different strategy, you're getting the same information or the same links and type of information coming up. A good thing to do when people are first learning is to widen this box again. So make sure that it is widened. So let's change our tool. We don't want to use our face tool there. So we're going to select. And what we're going to use for this is we're going to use the 3/4 bull nose. And again, comes in with all this information with it. Press OK. And that's now changed all the speed and feeds to correspond to this particular tool. With 3D adaptive clearing, a lot of the time you don't need to select the geometry. So go into the geometry. You can just let it go and remove as much material as it can. So I'm just going to leave it. But here, what I'm going to do in heights here is, look where the bottom is, it's right down at the bottom there, it's not right. So what I'm going to do is set the top height, because we've already had we've done the facing operation. So we now need to change that to the model top, so our current model top. And then the bottom height here, I'm going to put selection, and I'm going to select the top of that surface there. So this is how far down we're going to actually try and rough out. At this stage, we're forgetting about this end section that goes below the face. So as we're looking at this now, I'm forgetting about this little section here, because we're going to come back and do that in a 2D roughing strategy. This is going to be our 3D one, adaptive one, just as we're there. We can then go to the Passes tab. Now, let's make some modifications here. For instance, you can see the optimal load here is set to 0.3 inches. We can type in another value, or just let me show you how parametrics are everywhere inside of this. If I right click, edit expression, you'll see that optimal load of 0.3 is derived from the tool diameter multiplied by 0.4. I'm actually just going to change that to 0.3, and if I press OK, you'll notice and see that it's actually changed that there. So what that's doing, that's just lightening the load a little bit. Now we can also go down to the maximum roughing step down. So we go to the maximum roughing step down. If I right click, edit expression, this time you can see it's something math.min. I don't know exactly where that comes from, but what I want to do, I'm actually just going to change it, the step down, to 80% of the flute length. So if I just change this expression there and do multiply by 0.8 and that little bit, so 2 flute length times 0.8, and press OK, you'll see it's automatically changed them values, automatically calculated that length. This will also ensure that we are not just using the first 1/4 inch of the flute. So when you're machining, what sometimes you can do if you're not careful, you might have a tool that's got a long flute length. If you're only cutting all the time on the very bottom of that flute length, then that's where it's going to wear, and you're going to get uneven wear. So if you then come to machine something later on down the line using that same tool and it's got uneven wear, you're not going to get the same accuracy or the same model that you want. Plus, by using the parametrics, it also means if we change the tool to a different length, it will automatically update to 80% of the new length for the maximum step down for that particular tool. So by actually not putting in the value there, but actually using the parametrics to calculate the value, it means that if you change it, you change the tooling, it will automatically update. Lower down in the dialog, we can see stock to leave. So stock to leave here. So we can tell it to leave radial stock, or we can tell it to leave axial stock, or we can actually just turn that off so it doesn't leave additional material. We'll just leave this as it is for now. We can then go to the linking tab as we move across, and because this is a fairly big part, we're going to tell it to, because we have flood coolant on, which I showed you earlier, that the maximum stay down distance, we'll put that to 20 inches. And we'll keep that stay down clearance here. I'm just going to put that as 0.1 in there for that part. And we want to keep the tool down as long as possible and keep engaged as long as possible. If we're retracting a big distance, or we're constantly up and down, it just adds more and more time to the machining time. So if we say 70% stay down, so on the actual linking, on the stay down here, if we change that to 70% and then press OK, what you'll see now here is at the side, the adaptive clearing one is now just calculating the toolpath for us. So hopefully, very quickly, it's building it up. You can see the status telling us it's generating the toolpath. Because this tool can come down as low as it does, you can see the toolpath actually starts by clearing most of the geometry on the first level. Then it will start working its way up the part. The long yellow sections show that the full retract that we have between transitions. You also have the option of not having to fully retract, which we'll take a look at for finishing. So we've got that now. So it's still 69.4%. It's working its way through. And hopefully now that's that done. So that's now our initial machining path. One thing we didn't do though was this face here, if you remember. So let me do one more roughing pass. Let me go to 2D adaptive clearing. So 2D adaptive clearing here. I want to select this little pocket at the front and the two pockets to the side. So I'm going to select that one, and if I can select it, that face there. In the heights here, I'm going to set my top height this time to a selected face. So my top height now, selection, and I'm actually going to select this top face. So the bottom face from my last operation is the top face for this action. I will go to passes and linking and do some optimization again. So optimization on here. Yeah, looks okay. Linking, I think we said 20 inches. 0.1. I think here stay down 70%. And say OK. And this now should generate our next adaptive path there. You can see it's now working out, and it's now creating our cutout. One thing I really like to show people, and as soon as this pocket's done, which is great, is I'm going to choose Simulate in our Action tab. So what I'm going to do, I'm going to first of all select the full setup, and then in the top up here, if I select Simulate, it brings up the Simulate box. Now this has carried forward my information that I'd set in initially, but it shows here you can display the tool and not display the tool. This is now the Simulate dialog box. Let me pick if I'm showing the tool, if I'm showing the flute holder, etc. This particular tool didn't have a holder, so if you look at it over here, it didn't have a holder, it's just sat there. I can turn it to be transparent if I want, so I can actually turn the tool to be transparent or not transparent. I can decide how I want the tool path displayed whilst it's doing the simulation. So here I can actually turn on or off tool paths, but I can do all the tool path or just the tail. I quite like the tail one, so it will show a portion of the tool path but not the whole thing, and it will fade as it moves along. And the last thing I like to show is stock. So down at the bottom here is stock. There are a few options. Mirror is quite a nice one, and it changes different colours, but it can get quite confusing when you're doing it. So I just like to use actually ceramic when I'm doing it. And then what you can do when you're up to this is press play. But before I'm going to do that, let's have a look. Info. This gives us information on the positions of the tools, the speeds and feeds, the type of tool, and the statistics, machining time, the distance it's travelled, the number of operations, and the number of tool changes. So we've got all that information in here. If I press play, this now starts simulating and moving along. I've got some controls. I can move to the next move. I can speed, so I can increase the speed of the cutter as it moves along. You can see how the information, the position is changing in this information up here, what setup we're on. So it's faced the top, then it's doing our 3D adaptive clearing. You can see the depth of the tool in the material. We can pause the operation if we want to do. You can see we set a maximum of 80% of the flute length, which, you know, we're not near there. So there's a lot more of the flute length left, but as you're looking at it, you can see we're using it to as much as we can, the depth. If we zoom in, you can see a black line. So if we actually look here, that black line there, that is actually our finished model size. So you can see we're actually leaving some clearance there from it. And what we'll also see down at the bottom here is this green line. Now, if there is collisions or there is a problem, you'll notice later on there may be some red parts, which might be to do with the length of the tool that we're using. So I'll just let that go. We can move on to the next step. Speed it up even quicker. There we go, as it's going down. I say currently there's no collisions, so there's no red dashes in there. You can see the values changing, there's tool moves, different operations. So these are the sort of the things that you can show when you sit down with your student. You can point out little things like that. You can really show you understand the things that they are concerned with, and that will help them to engage with you and to help you walk through their needs. You can show you have some understanding. I'm always upfront with the fact that I'm not a machinist, I'm not a machining expert and can't do their job, but I have an understanding of this tool that I think can do their job, or is being used by the same people that is doing the same job as they do, and they appreciate the honesty and your expertise in a tool that they don't know but can take advantage of. So now that we've roughed this out, yeah. So what we can actually do now is take a look at finishing. So looking at the time, I just want to get through, so I'm not going to go back to the PowerPoint now. So let's open the 3D finishing model So I'm going to close that now. Close out of that. And if we go back to 3D finishing here and open up this model here. Yep. So just like before, you can see now there's some extra operations that have been put in here. The boring the holes and stuff. And if you wanted to see all the strategies, you can click on it, each one, and you give an indication of the tool paths and what's happening at each stage. So once again, to apply this 3D finishing, I'm going to go into the 3D tab. Now we've got quite a number of operations here that we can select. The one that I'm going to use initially is the parallel finishing, where the tool is going to move up and down in a parallel direction, and just move from one end of the stock to the next end of the stock as it's going along. First thing, we need to check out, we've got the same tabs up again as before. If I go select, yeah, this time I'm going to change my tool to the 1/2 inch ball end mill. So we've got here 1/2 inch ball end, all the information comes through, press OK. This updates all this information here with the speeds and feeds. I need to now go to the geometry tab. Yep. I'm going to select my option to selection. So in here, I'm going to select my option. We've got boundary box here. We've got silhouette. We've got selection. Different. So I'm going to click selection and selecting the machinery boundary of the element, the inside and outside of the handle. So what I've got to do now is select the inside of this, the boundary of it. So it highlights yellow, and then the outside. But I don't want all this. This is not the outside boundary. So I'm going to click it again. I've selected that. Can I select that one line? And it might be that I have to go around and select each one of these. Come on, there we go, got that one on. I'm just going to work my way around this model. I don't know why it didn't automatically select, but there we go. Just going to work my way around this. Let's just move this around a little bit there. Got that one. We'll select that. Got it. And then we need to come into this bit here. I need to select that. There and there. So we've actually now got all of them sections around it. There. So if I click plus, that will add now the outer boundary. So we've got the inside the handle and we've got outside. We want to make sure, or we've made sure, the contour is closed, but it could be open or closed, but on this one we're going to make sure that it's closed. Now one thing I would like to do is set the tool containment here to be outside of the boundary. So that's meaning that the tool will not go inside here and cut the stock, so it's always going to remain outside. So the tool can go outside of the boundary. So the tangency of the ball end, or the cylindrical surface of the ball end, is allowed to go outside of that boundary in order to cut the geometry. You can restrict that, holding things in or not. I would like to select a few faces to avoid. So what we've got here, down at the bottom, we've actually got, we put in here, faces that we don't want the tool to touch. So I don't want it to touch this flat surface here, that one there, this surface here. And if I just twirl this round, I don't actually want it to touch that surface or that one. So we can actually, that can actually be, because it's actually avoid or touch surfaces. So the option there, you can actually say, I want you to focus on this surface and these surfaces. So touch these surfaces, please. Or you can actually have it the opposite way around and saying, I do not want you to touch these surfaces. So the way that this is set up at the minute is I don't want it to touch these surfaces. I want it to avoid them. So that's why I don't want it to touch them. So that's the way that I've set it up. On the passes tab here, the step over is currently set to 1/4 of an inch, which is not very fine for a finishing pass. So what I'm going to do, I'm going to change that to 0.05 of an inch. I want to set the pass direction. The pass direction is the direction that the tool is going to move. So when I look at the contour, the pass direction is based on X. So if I want to make this tool path, the tool would be going back and forth on the X-axis. Because it's a parallel tool path, it will move in a parallel fashion. But really most of this contour is in this direction, which is in the Y direction. So I'm going to set my pass direction to 90 degrees. So rather than it be going up and down this surface, it's going up and down in the Y direction. Then I'll tell it to go ahead and put a tick in the machine the steep edges. So we've got machine steep areas there. Then finally, let's go to the linking tab. And to save a lot of tool travel, because a lot of the material will be down at the base level, I'm going to tell it to go to minimal retraction. So here, rather than 4 retracts, I'm going to go minimum retract. So let's say OK, and let's have it develop that tool path. So you can see now it's working away here, and it's now created that tool path there for us. If we want to look at see how it's finishing now, if we're going to setup, go into simulation, keep the same settings I had before, press play. There we go. Fast forward it very quickly. So you can see now how this is starting to machine out my design or my model. So that's all the roughing, the counterboring, and this is now our first finish pass. Now what I'm going to do, as it's going through here, you can zoom in, and you'll notice you can actually see what the tool has left, the sort of grooves that are in there. So that's actually going to take quite a bit of finishing when it's done to get it all nice and smooth. So another thing that we can do is we can actually send another pass. We can actually duplicate it. So let me just close this simulation a minute. And what I'm going to do, if in this parallel path here, I right click, I can duplicate. Then if I click on it, right click and edit. I want to keep everything the same tool, the same geometry, same heights. The passes though, rather than being at 90 degrees, I'm actually going to put that at 45 degrees. I'm actually just going to change angle, I'm going to keep the linking the same. If I do OK, it's now going to run another pass of this tool, but instead of going, you can see now it's going at 45 degrees across rather than 90 degrees. So it's now taking the tops off these troughs that we've done, or these peaks from the troughs. Then we'll go back to setup, go to simulation, go to the end. As you can see down at the bottom, there's actually some red little marks that are starting to appear. These are collision marks. These might be to do with the length of the tool that's being used. So what you can do, you can go down and investigate them, go back to them and see where the collision is. But a lot of the time it might just be the length of the actual tool that's being used. You might just have to increase it. But that's our 90 degrees. And again, if I zoom in, yeah, you can actually see now where it's got like the cross effect, where the tool's coming across at 45 degrees compared to 90 degrees, and it's that there you go, it started to to do it across here. So it started smoothing it, so it's giving it a bit more, a better finish and less work that's going to have to be done on it. So the final thing that I want to do is I just want to run one more toolpath on this that I want to apply this time. I want to keep the same tool, the same geometry, the same boundary conditions, the same everything apart from the technique to cut it. So I can't just simply duplicate. So what I can't do, let me just close that now. What I can't do is just like we did on here, is duplicate. I can't just simply do that because I'm going to be using a different technique. What I'd like to do is, or what we can do is tell it I'd like to create a derived operation. Now, one thing about derived operations is you can't have a 2D toolpath drive a 3D toolpath from it, or vice versa. You can't have a 3D toolpath drive a 2D toolpath. It has to be from a 3D to 3D toolpath or a 2D to 2D toolpath. So here, I want to change from creating another parallel to creating a scallop toolpath. So if I click on this one, right click, and create derived operation, 3D milling, and go to scallop, there, I'm keeping everything else the same. So if I just go OK, and that will now create a scallop, and it's the, if we look on here and hover over the scallop, you can see the type of toolpath that it will go. It will follow around the shape, and that's our final pattern that we've done. So you can see how this toolpath works. It's way around the geometry. So if I was just to simulate this bit here, and so I just took the full stop. I'll just close that. Looking at the time, so you can see how this will actually just follow around the actual contour. The final bit now. So we've got this now. We've got our machining paths there. But again, you're going to be able to work with your customer and help them understand what's possible and works for them. So now that the toolpaths are done, we're able to go back and start taking a look at the outputs. So if we go back to setup in here, we can get the setups and the setup sheets. So up at the top, we've got setup sheet. So if I click setup sheet, it asks where do you want to save it. Press select folder, and what happens is it will bring up that tooling for me. It will bring it up in a separate window, and there we go. So straight away for this one now, it's telling us our work coordinates, our stock, the tools that we're going to be used, the setups for each tool, the operations. As we go down, so you can give this to your tooling room that can set up all the tools ready for you, for your machining. And then finally, what I want to show you as well, so I'll just do that, knock that down, is we've got our post-processing operations. So you can go to setup, you can set up for your machine, so you can set up for your post-processor that you'll have. You can pick, so on this one I've just got to set it up as a Denford machine. You folder where you want to save it to, program numbers. If you press post, select a number for it, so I'm just going to select that one, save, replace, and then that's now creating my G codes. And there we go. This is then all our machine coding, all our encodes, all our coordinates, all our Gs, tool changes, everything's in there along with the tooling list. So all the G codes are there, all the information on the tooling changes, you can program in manual stops, you can build it in, everything you would expect from a mature CAM program has been built into Fusion 360. So that one opportunity to be aware of, people that are using old systems in the machining workspace, Fusion is catching on really fast. There are a lot of people out there talking about it. So if you're a training centre that is part of a reseller partner, go back to some of those accounts that you've have had for a while, go visit them, see the guys in the machine shop and see if they have heard about Fusion 360. If you're a standalone training centre, reach out to some of those places and put the word out that there's a new tool, new tools, new technologies available, and that you're ready and able to get them up to speed on something that will make them more productive.